This is an actual board used in today's governor school class, third day class. And I sketched a graph, but everybody was given a graph of an exponential function, totally unlabeled, and was asked to verify that the graph is exponential, which is easily done because an exponential graph has a property that has a constant doubling displacement. So pick a point on the graph, see what the y value is. Move over until the y value is twice that great and you've got your doubling displacement. If it's an exponential function, well, move over that far again and see if the y value doubles once more, etc. So you just do that with the graph and it works out that way. Now, the thing that we're going to do here is we're going to look at the slope of this graph at the point where the graph reaches or crosses the x-axis. And we're going to assume this is an exponential of the form, exponential function of the form f of x equals b to the x for some number b. Now, it should be clear from the fact that the graph is increasing that that number b would be positive, but other than that, we don't really care that much about the number of b right now, the number b. The only thing this tells us is relevant to this graph, because the graph is totally unscaled, that if x equals 0, then b to the 0 being 0, y has to equal 1 so that the point 0, 1 is on the graph. And of course, if you have an exponential graph and you've been able to verify that it's an exponential function and you know it's of this form, then you know this point here is 0, 1. Okay, well, we want to see what effect the doubling distance has on the slope of this graph. Okay, so the doubling displacement, I should say displacement because the doubling displacement can go in the positive or the negative direction. If the doubling displacement is denoted by delta x sub d, change in x that doubles, if you like. How does the value of delta x sub d affect the slope at this point? Now, we're not going to actually be able to calculate the slope at this point, but we can get an inequality, kind of a double inequality, that gives us an idea of what that slope might be within a certain range. Okay, so what I've posed, the problem I posed is, if delta x sub d equals 2, then what are the coordinates of point 1 and point 2? Now, point 1 is here, and I should probably label the coordinate at this point. This is a doubling displacement to the left of the origin. This is a doubling displacement to the right. So I could say that this coordinate is negative delta x sub d, and this one is delta x sub d. So what do? I draw a chord from the graph point where the x coordinate is negative delta x sub d. In other words, the graph point 1 unit to the left of the y, or 1 doubling displacement to the left of the y-axis, and at the graph point that's 1 doubling distance to the right of the y-axis. And I think I got a little confused in that statement. Let me be clear what I'm saying again. We draw the chord from the point on the graph 1 unit to the left of the one doubling displacement to the left of the y-axis to the point 0, 1, the y-intercept. And then we draw a chord from the y-intercept to the graph point that's 1 doubling distance to the right of the y-axis. And we call those two chords chord 1 and chord 2. And then this red line is what we'll just refer to as the tangent line. Tangent line at the y-intercept. Now, one thing that we can see clearly from the graph, if this is an exponential function, and we haven't proven it, it remains to be proven, but we can say with some confidence that the slope of the tangent line is greater than the slope of this chord to the left and less than the slope of the chord to the right. There doesn't seem to be any doubt of that, and if we're confident in our ability, we can move on, understanding that if we want to really publish a proof of this thing, of what we're going to do, we're going to have to come back and patch up that little detail to show that the slope of the tangent line really is between the slope of this chord and the slope of this chord. But for now, we're going to take that as something, again, that we know we can come back and patch up, so we're not going to worry about it right now. We'll worry about it later if necessary. If this analysis leads us to anything that we think might be worthwhile. Okay. So now I say if delta x sub d equals 2, what are the coordinates of point 1 here, and point 2 being here? Then what are the slopes of chord 1 and chord 2? What's the slope of this chord? What's the slope of this chord? Then we have a question for what doubling displacement, for what delta x sub d is the slope of chord 1 equal to the slope of chord 2? I'm sorry, is the slope of chord 1 equal to 1? I'm sorry, I was a little distracted. Something popped up on my computer screen. No excuse. So, for what doubling displacement is the slope of chord 1 equal to 1? And the same question for chord 2. For what doubling displacement is the slope of chord 2 equal to 1? Okay. What's the ratio of the slopes of chord 2, say the slope of this chord, to the slope of this chord? Okay. Now that's unrelated to these two questions. Just for a given doubling displacement, what's the ratio of the slopes? Does that ratio depend on the doubling displacement? Would it be different for different doubling displacements? So, for example, if we calculate these slopes for a doubling displacement of 2, and they come out with a ratio of 7.3, let's say, if we calculated them for doubling displacement of 3, would they still come out the same? Can we deal with that sort of question? Another question, if the doubling displacement doubles, what happens to slope 1 and slope 2? Okay. Now, if we look at the question up here, for the tangent line at 0, 1, that is for the tangent line I've indicated here, I'm writing down what I asserted earlier and what seems obvious, that slope 1 is less than the tangent line slope is less than slope 2. Slope 1 being the slope of chord 1 is less than that of the tangent line, and that in turn is less than the slope of chord 2. Okay, then if x sub d equals 2, well, what are the slopes? Well, this is a question that people had no trouble answering once they got the coordinates of these points. So I'm going to come back and talk a little bit about that before we move on to the more general questions. People found that for xd equal 2, the slope of chord 1 was 1/4, the slope of chord 2 was 1/2. So slope 1 was 1/4, slope 2 was 1/2. So whatever the tangent slope is, then if xd equals 2, the tangent slope is between 1/4 and 1/2. Then there's the question of, if the doubling displacement is 1/2, then what can we write? What would the inequality be? And that was left as kind of an open question, but I can fill that in now. You're going to get 1/2 less than the tangent slope less than 1. And I think what I just wrote isn't right. It should be 1 is less than the tangent slope is less than 2. Okay, we're going to come back and talk a little bit more about this. This is something one of the students wrote in answer to this question. And then we'll move on a little further.